Okay, time to start, right? This is Krishna Vidula, your facilitator for the IFIS webinar series, and we are just delighted to have with us Dr. Will Williams. So good morning, good afternoon, good evening to all of you in different parts of the world, and we have an exciting webinar for you today from Dr. Bill Williams. From the Center of Management Studies, Institute Superior Técnico, Universidad de Lisboa, Professor Jubil, and also Professor Jubilado of Institute Politécnico de Setúbal, Portugal. I hope I got some of those words right. The topic is interdisciplinarity in engineering education research, challenges and rewards. A little more details about Dr. Bill Williams. He originally trained as a chemist at University College Cork, Ireland, and went on to work in education in Ireland, UK, Eritrea, Kenya, Mozambique, and Portugal. So he really understands the international scene on this engineering education, and he went on to run international distance courses, educational courses for distance courses for International Labour Organization in various African countries. His research interests include engineering practice, gender, and the global evolution of engineering education research. He's a member of the Center for Management Studies of the Institute Superior Técnico, Universidad de Lisboa, Professor Jubilado of Institute of Politécnico de Setúbal, Portugal, and also an adjunct senior research fellow at Technological University Dublin in Ireland. He's a founder member and current vice president of the Portuguese Society for Engineering Education. So I'm delighted, and I'm sure you are also, to have with us Dr. Bill Williams, and I'm going to just make him the presenter, and we will be ready to go. Bill, I've made you the presenter, so you just have to click show my screen, and your screen will be visible once again.
Great.
Perfect.
Thank you very much, Krishna, for that nice introduction. And I'm looking here and I see 67 attendees, so it's kind of exciting.
It'll increase. A few more people join at the last minute, so it'll increase.
Yeah. Now, my is aimed principally at people, scholars who are relatively new to engineering education research. In other words, I'm thinking that you probably have a background in engineering research or perhaps natural sciences research, and recently you've got interested in EE or engineering education research. But I hope even if you're an old hand, I think some of the data might be of interest. And we're going to look at three topics. First of all, interdisciplinarity. Secondly, strategies that you can adopt if you want or need to work in an interdisciplinary way. And finally, choosing a journal to publish your work. And first, perhaps definition. Well, here we can see that it's sort of a continuum. So a multidisciplinary approach is one where you have people from various disciplines, but with not very much integration between them when they're working together. Interdisciplinary work suggests a high degree of integration. And finally, transdisciplinary is when perhaps we have such a high degree of integration that we can think of it as a new field of study or a disciplinary field. Some would claim that engineering education research can now be considered a discipline in itself. So first, let's look at some data from journals. For example, there was a study we did where we looked at 6 journals in 2011, and we were interested in the disciplines that were underpinning the studies that were published in those 6. So here are 4 of the 6, and we can see for advances in engineering education, we had these ones, the Australasian Journal, whereas chemical engineering had only one really. It was more focused, I guess, on disciplinary engineering disciplinary approaches. The EJE, European Journal, as you see, had quite a range. And then if we look here at the JEE, the Journal of Engineering Education, really you can see that the studies that were published in 2011 really had quite a range of disciplinary backgrounds underpinning them. Also in that study, then we thought, right, so if we have these non-engineering disciplines underpinning the research that's been published in engineering education journals, what about the actual affiliation, the background of the authors? So this gives you an idea for the same 6 journals of the number. For example, JEE was the one that had the highest number of researchers from disciplines outside engineering. And you can see education psychology, which I guess is what we'd expect, but also sociology, etc. And likewise, for the European Journal, there's quite a range as well. So that study showed that in these published articles, interdisciplinary work was important, and it seemed that the engineering educators were working with colleagues from other disciplinary traditions to do these studies that were published. Then another study we did gives us more of a historical to see how things have evolved over the last 40 years. This study, we just looked at AEE and its European counterpart EJEE, and we see in the early days, really, most of the articles published were, very much engineering focused, and whereas by the time we got into this century, especially JEE, it really took off in terms of interdisciplinarity. And finally, in terms of the reference disciplines or if you like, outside disciplines underpinning the studies in these 2 journals, JE and EJEE. Right, so here we can see by 2013, then the JE articles had quite a range of interdisciplinarity. So they were being underpinned by community studies, gender studies, cognitive science, ethics, philosophy, and likewise notable contributions in psychology and other fields for the European Journal. Right, well, so that gives us a sort of a picture of what was going on in some of the studies that were being published in journals. Now, have a think. Where do you think an interdisciplinary approach would be relevant to you in the kind of research that you want to do in your institution?
So you want them to chat about that?
No, not at this stage. No.
Okay, you're just having them reflect. Just want them to reflect. Okay, got it.
But thanks, Christian, because further on there will be occasions where I'll be asking people to make suggestions and give their ideas. But right now it's just reflect.
Yep.
In terms of students, for example, things like student motivation, diversity, engagement, learning. It's the kind of things that one is trained to do as an engineering researcher or a physics or a maths or a chemistry researcher really in many cases won't be very helpful here, because the kind of research, the kind of data that we need is of a different kind. Likewise, when we want to know more about the engineering workplace, James Trevelyan and myself have collected a lot of data about what engineers do in the workplace, and we found that we had to learn concepts, frameworks, ways of doing things that from the world of social science.
James is with us, by the way, Bill. James is with us.
Okay, great, right. So welcome, James. And so these are the things. These are the areas that we could think of where interdisciplinarity is certainly relevant. However, Michael Milligan, in his webinar some weeks ago, actually, and you probably know he's the CEO of ABET, he went a bit further, because he said, if you look at top 10 skills that have been identified for 2020 for engineering professionals, this is based on Future of Jobs report from the World Economic Forum. In addition to technical competence, which is taken as a given, engineers in the future are likely to be expected to address all these things here: people management, emotional intelligence, judgment, decision-making, negotiation, cognitive flexibility. Now, most of our engineering schools don't really do a whole lot about these areas. But I think it's safe to say that more and more we will be expected to prepare our graduates so that they have these skills. And if we want to adapt our curricula to make them more relevant, to make our graduates more competitive in engineering enterprises, then we need to have ways of measuring how successful or not we have been in giving our students practice in developing these skills. So Michael Milligan also then said that based on that, he suggests that these are some of the important ways that social sciences can aid engineering. I'll give you a second to read these. Okay, now, if my logic so far has been to show you that in the field of engineering education research, interdisciplinary work has a very important place. And if you're relatively new to this, then you may well be thinking, okay, but I don't have a background in that. So how do I go forward? Well, from my own experience, I think there's two ways forward, and I've sort of explored both of them with varying degrees of success over the years. But basically, we're talking about either you find people to work with who bring those skills, of social science, psychology, education science, sociology, whatever. So you identify the right people and work with them in a team. And as we saw from the data earlier, a lot of researchers do that. However, let me say from my own experience, it's not just a matter of looking to see who is an education person in your institution and grabbing them, because really you need to be working with people who have a feeling for engineering. And you need to get the right people to bring an interdisciplinary vision to your team that you can work with. Now, if you're based, say, in a research university in the States, for example, then that might be relatively easy to find people that you can work with. However, if you're somewhere else in the world and perhaps you work in a polytechnic or a technical university where there aren't social science people or education people, etc., your other strategy is to go it alone. In other words, to immerse yourself in the kind of social science instruments, concepts, frameworks that you will need for your particular students to be able to study your particular situation. So that's basically it. Either team up or learn and immerse yourself. And I'll come back to that a bit later, because first of all, I think it would be useful if we look at some of the journals in the field, because, right, you do your research, you're very pleased with it, you've got good data, you've got interesting findings, you want to share them, and ideally then you would like to publish them in one of the better journals, right? So let's look at some data from some of the top journals in the field to give you a feel for what you need to think about in terms of submitting to journals. For example, here we have JEE. As no doubt you know, it's perhaps the most highest rated among the journals in the field, has the highest impact factor and so on. And these were the submissions from various countries between 2015 and 2018. So, well, you might be able to guess which of these countries were most successful in getting their submissions published. Right, so there we have it. Now, looking at those columns, there's one particular one that I think is important for our conversation here today, and that is here, reject on submission. This is what you don't want to happen to your submission. So we see with the Australian ones, nearly 50%. The Brazilian submissions in this period, more than 50. So right down here, in many cases, the majority of the papers submitted had the boomerang effect, came back to them with a reject. So they didn't go out to review. I'll return to that in a second. So that's the situation for JEE. Let's look at two other journals then, the European Journal. And here, well, a broader spread geographically of published papers. It seems like well, it's pretty global, isn't it? But the Northern European and Dutch ones were perhaps a little bit more successful in terms of getting published. And finally, IEEE transactions, again, geographically quite a reasonable spread here. So the data from those three journals, I think they show us pretty clearly that it's not that easy to get published in these journals. So you may ask yourself, well, if I'm very likely to get rejected and not get published, why should I submit to one of these journals? And this is the important point. If you submit to a top journal and your work is sent out for review, it's very likely that it will go to real experts in the field, the kind of people that you are citing in your paper. Now, if you're somewhere, well, like me in Portugal, somewhere where there aren't that many other people working in this field, so it's maybe not so easy to get, to have conversations, to get comments, to get suggestions on your work, then to have leading world scholars commenting on your work is really quite a privilege, I think, and that's what we would want to be aiming for. So I'd say submit to the best journals, and I'll come back to choice of journals in the last part, and aim so that you get past the first stage, which is a decision by the editor to send it out to the associate editor and send it out for reviewers, or desk rejection. So desk rejection is what we want to avoid. So some suggestions then about avoiding desk rejection. There was another study that we did. This time it was on papers submitted to the CEFI journal, the European Journal, and CEFI conferences. And we'll look at you know, the normal sections of a research article, which are these here. And we identified the ones that gave most difficulties. So have a look at the list and write down in the chat which areas you think were most problematic from those sections.
Okay, here's your chance. We have 105 people with us. We need responses. Hey, 105 responses maybe, so we can read them out. Let's go at it, gang. Chat session. There's a chat box in there. Just get into the chat session and keep coming in, and we will. Do you want me to read them out as they come up, Bill? I can do that.
No, I can see them here.
You can see them yourself? Okay, great. And then you go ahead, yeah.
No, I can't actually. I can't.
You can't? Okay, yeah. If you want, I can make you able to see. Would you prefer that?
Yeah.
Or I can read it up, but whichever you think might make sense to you. Which would be easier for you? I can read them out, like methodology. Okay, procedure or methodology, findings and discussions, research questions. I would say most problematic is methodology method. So
okay.
Keep coming. I've got 5 minutes so far.
Okay.
I need more. So I'll keep reading it out that way. Another one on methodology. This is Roger Hadcraft from Australia talking about methodology. Yes. And then Bridget.
Okay. If you said methodology,
methodology. Then Deepak Waikar saying discussion. Rama says finding and discussion. Patrick Xavier says methodology.
Okay, great. Thank you, Krishna.
Ravindra says research questions, etc. Okay.
Yeah, we're good.
You get the idea. Okay,
yeah.
All right.
So methodology, research questions, and also limitations were the most problematic ones. And the point here is that many of them had a section called methodology, but it was actually methods and procedures was what we found. So methodology is challenging, research questions also. So I'm going to give you some suggestions about those two then right now. Research questions. I've had a lot of conversations with engineering colleagues who say, what are you going on about research questions? In my area, we talk about research objectives. Why are you making such a fuss? And my response is that research questions, organizing your ideas in terms of a question tends to oblige you to focus more on what you really want to analyze. Whereas, my heart sinks a bit when I get something to review and I see it talks about objectives. Because if you have clear research questions, it helps you clarify what you want to analyze, and it helps the readers also see at the end if you have answered those questions. So you're helping yourself as a researcher, and you're helping your readers, which is good. Now, if you come from one of those traditions, where you work more with hypotheses or objectives, then this particular article by Shavelson and Town, we have found it's pretty useful. It gives you some suggestions on thinking about kinds of research questions that you can apply to your situation. Right, so that's research questions. Moving on to methodology. Like I said earlier, methodology can be challenging if we're coming from non-social science research traditions. So, for example, if In social science, they use instruments like grounded theory, ethnography, action research, phenomenology, phenomenography, etc., which look pretty strange to many of us from science and engineering background. So what I recommend is, an excellent article from the 100th issue of JEE, where for each of those methodologies up there, it explains what it is, explains why you might want to use it, and it gives you an exemplar study that has used it. So I think that's like a classic paper that will help you to see how these particular methodologies can be useful. Then qualitative research. There's been a lot of good papers recently, but it's fairly recent really, that engineering educators have started, I guess, giving more emphasis to qualitative research. Work by Walter Soshaka and Kellum. This paper, for example, gives a good overview of qualitative research, how we can identify quality in qualitative research, and it also has in the references, it has almost, I think, all the ones that you would need to get a solid grounding in qualitative research in our field. More generally, in terms of books, we'll probably give you a general view. People in Europe tend to go more for this Savin-Baden one, whereas other parts of the world, Cresswell is books on mixed methods, qualitative research, etc., are the sort of the classics. And finally here, when we're talking about methodology, if you're thinking about doing a systematic review, then this paper here, there've been a couple of papers by Mora Borrego, Foster and Freud. If you look there, it gives you everything that you need to know about, I would say anyway, about applying systematic literature reviews or meta reviews in engineering education. Right, so I'll be leaving a PDF with Krishna afterwards if you want to check these resources. And now thinking about journals. And here, this is one where I'd like you to write something in the chat. That is, here are 11 journals. How many of these 11 journals can you identify from the acronym? And have a look and write down the number.
Okay, let's do some assignments here. Those of you who can recognize any of these journals, expand on their names.
Yes.
And write it down.
You don't have to say the names, you just have to write how many of those 11.
Oh, I see. Okay, how many of those do you have? That's a good point.
Just write a number.
Just write a number. How many of these can you recognize? Okay, great. We got a number 4, 3, 2, 2, 6. Ryan Campbell says 6. Deepak Paikar says 3. Ramindranath says 4. Richard Yang says 11. Divya says 5. Rama says 5.
Okay, right.
7.
Okay, let me just stop there. I was just going to say, if you said 11, I think you're cheating. But maybe I should have been humbler. Obviously, there are people in the audience.
So there's one that's not a journal. It's a trick question.
Here's your opportunity. Here's your opportunity to check. Yeah. There you go.
Maybe it's a trick question. Yeah, but go ahead. Yeah. Okay, this is an opportunity to check which ones. Yeah, great. Mm-hmm.
Right. Anyway, so there are 11 journals. There are more, obviously, but these are some of the ones that you could be thinking of submitting your interdisciplinary research to. So these 11 journals. This is my final question to you. Of these 11, I'd like you to identify 3. And the 3 are the most expensive to get published in, the least expensive, and the easiest to be published in. I'll say that again. Most expensive, least expensive, and the easiest.
Okay, you want them to write them down? Okay, let's see what they say.
Well, yeah.
Think about it. Yeah.
Yeah. Have it. Yeah. Write them down if you think you know the answer.
Yeah. You know, one of them, Patricia says, most expensive is Journal of Engineering Education, JEE. Let's see other reactions. Another one says, okay, they've given the name journal, but after you're telling me which category, most expensive, least expensive, and the easiest. So just make sure you mention the category. Don't just mention journals. Yeah. 3 categories, right? Most expensive, least expensive, and easiest. You need to tell me which of those categories you're talking about. Don't just give me the names of the journals. Come on. Which easiest. Okay, SJEDU. Keep going. Others who have.
Okay, let me perhaps give you some extra information which might confirm or might refine your suggestion.
Right. Somebody wants to know which is the easiest journal so they can submit it to it. Okay, go ahead. Yeah.
Right. So there you see the ones that are indexed in Web of Science. You can see the Scopus quartile. So normally you'll find these journals are in 2 categories, at least 2 categories in Scopus, and 1 is the highest quartile, and then 2, 3, or 4. So EJE is in the highest quartile, I think, in engineering, and in second in education, whatever. Okay, so right now you get your opportunity to see the most expensive and the least expensive. And well, we see that the most expensive, actually, if it depends on the number of pages, but I did these calculations for a 15-page article, and in that case, it's the International Journal of Engineering Education is the most expensive. The least expensive, well, we're talking about the European Journal, the Australasian Journal, and IEEE Transactions if you don't go over 8 pages. And finally, the easiest, I think somebody has already given the answer actually, it's this one down here, the Science Journal of Education. Because as far as I can see, as long as you pay your money, they'll publish it. It's one of those ones that it's from a publisher that was listed in Jeffrey Beall's list of predatory publishers. So, you know, not to be recommended. Right, so there you have the options that you could be considering for publishing your work. And that's, I'm just coming to the wrap up now. So basically, I hope I've shown you some useful data on the kind of stuff that gets published, on the kind of fields that can be useful to us, and the techniques from other fields that you might like to apply, or you might need to apply to know and have evidence and data to support the initiatives that you're doing in your classroom, in your curricula, etc. I'll just, yeah, here we have some of the references that I've used along the way, and I hope that the data and these ideas that I've shared with you and the recommendations I've given will be useful to you as you go on to be a successful scholar in engineering education research. And now I'll hand it back to you, Krishna.
Okay, thank you, Bill. I just want to, before opening it up for discussion of the panelists, just I think mention that in fact there is another journal which I have a vested interest in, actually, because this is something that I helped work with. This is the Journal of Engineering Education Transformations, JEET, that the Indo-Universal Collaboration for Engineering Education is helping a college in India host it. So that's the Rajaram Bunch of Technology. And it's definitely not the easiest, because we have Som Sohoni from Milwaukee School of Engineering is the chief editor on that, and he's really very tough on, and he's got a team of people all from global people thing. And it's been a couple of years ago, it became Scopus Index, and it is free. So I just wanted to mention that, because I know we haven't had a chance to send you that information. It's a couple of years old, and in terms of Scopus Index, I just want to mention that, and maybe I'll, at some point I will send you the details on that, Bill, so that you can give us your thoughts on how to make that a more visible journal. But in the meantime, let me go on to the folks who have been with us and see what questions and comments people have. Why don't I pulled up a few people into the panelist category, because I thought they might have some comments to make. I pulled up James Trevelyan, Elsie Meow, and Roger Hadcraft and Ramiro, and I'm hoping maybe some of these four could make some initial comments and their thoughts on what you've done, and look for comments from the general participants and questions from them, and I'll read them out. But let me open up, James. Would you like to jump in here and maybe add your 2 cents worth, or whatever, or $2 worth, whatever you consider? Go ahead, James.
Thank you very much, Krishna. I hope that you can hear me.
Sure, you do.
So Bill's given a wonderful introduction. I thought I would just add a couple of comments that, while aspiring for journal publication is a really good idea, the intermediate step is to aim for conference publications. And there are lots of conferences to choose from. Conferences generally are much more accepting of contributions from prospective authors, because as a conference organizer, you know that everybody that you send a rejection letter to is probably not going to come, and it's going to undermine the financial viability of your conference. Having said that, there are some conferences that do actually have quite high fences to jump over in terms of acceptance, and obviously you will get better quality reviewing at those conferences. But definitely a first step is to get a conference paper submission, and preferably more than one, so that you've got a reasonable chance of having something accepted. Having reviewed lots of papers, and I might say Bill tosses me papers every now and again to review. Thank you, Bill. It's always a stimulating experience. As a reviewer, the most common issue that I find is and this is particularly the case, I think, amongst engineering writers, is the difficulty of creating a logical argument. And for engineers, we're used to arguing in terms of mathematics. It's a really tough transformation to argue in words. And that's one of the biggest obstacles to overcome. The other is to adequately address the literature. And this is where reviews can be really helpful, because reviewers will always be able to suggest literature that you haven't come across. And as a reviewer, what I try and do is give as much details about the literature as possible, citing references wherever possible. If you get a review back and they say there's lots of literature on this, and they haven't given you any idea of where to look for it, they're not being a very kind reviewer. So, definitely that's something I aim to do, is to help people who are writing papers understand where literature exists that they should really refer to. Because after all, the whole essence of publishing, particularly in a journal, is that you're building on work that's been done by others. And it's terribly important to make sure that you are building and extending our knowledge, rather than simply creating something that's been done before, simply because you haven't been bothered to read the appropriate literature. And one of the quickest ways to get a rejection is to try and do something that has been done before. So sometimes that can be tough if you're starting out. I can remember when I got involved in engineering education, engineering practice research, it took about 5 years to get to the point where I was reasonably comfortable with at least the main areas of literature, and probably 10 years before I was really comfortable and I could say, yes, I think I've covered most of the stuff that needs to be done. So there's a few extra comments for you.
All right, fantastic. Thank you so much, James. That was very, very enlightening. I'm going to go to Roger Hadcraft next from Australia also. Roger, would you like to jump in and make some comments? I'm going to unmute you and see if you can unmute yourself. You're self-muted right now. I'll go to Ramiro also. Okay, go ahead, Roger.
Okay, thanks, Krishna, and thanks, Bill. It's great to see all this conversation again. I'm sure I've listened to one of your presentations before, but it's good for the refresh. Very, very helpful. I think we forget that engineering itself is an interdisciplinary business. You know, we often teach it, as you pointed out, as if it's all about technical stuff. It's about applied physics and chemistry and solid mechanics and things. And, you know, at our university, we have a set of graduate attributes or capabilities, and there are five of them. And apart from one of them, they're all social processes. And so, you know, there's social engagement. What problem are we solving? There's design processes, which are inherently social. There's collaboration and communication. There's personal reflection. And finally, of course, there's the grand technical discipline that we think is so important. And I think the tragedy of engineering faculties is that almost all of our research is concentrated on that fifth thing, that technical engineering science, effectively, and the desperate need for us to better understand all the other processes that make up the business of engineering practice.
Okay, so thank you, Roger. And I'm going to go to Elsie had some comment, but before that, I'm going to go to Ramiro. You want to unmute yourself, Ramiro? Jump in, Ramiro, if you would like to. Yeah, go ahead, Ramiro. Well, just speak up and you should be fine. But and then we'll get to Elsie. Ramiro is having some difficulty, and others, please jump in and yeah, Elsie, go ahead. Elsie, go ahead. Yeah, okay. Yeah. Who's that?
This is Bill, actually.
Yeah. Go ahead. You had some comments.
I'd like to just
add some. Yeah, go ahead. No.
If I could respond very
Absolutely,
quickly.
Yes, of course. Yes. Go ahead, Bill. Yeah, respond to both of the comments you heard. Yeah.
First of all, thanks, James, for bringing up the thing about conferences, because actually that's the advice I normally give to people that I'm working with who are new to the field. It's through conferences that you will get a feeling for it, not only for the work, but for the people, and that you will make contacts, make partnerships. You know, my colleagues used to rib me and say, but you all seem to be traveling to conferences, you know, and I did it because I quickly discovered that's the way to really get a you know, to get a handle on this, what appeared to be a very challenging, difficult field initially. It's by knowing the people and talking to people and sharing, etc. My focus today was more on journals because I happen to have data from journals, and I don't have so much. It's more difficult. We did some analysis of conferences, but it's a bit more complicated in terms of data. And sure, I couldn't agree more. And this is for submissions to conferences or to journals, that when you're writing up your work, you should be showing that you are familiar with the conversation in this particular area. Like, you know, if your study is to do with gamification or with gender issues or active learning or whatever, it should be clear to the reader that you are completely comfortable with the ongoing conversation about this, and what you then are bringing to the conversation to move it on. And Roger, your point, it's absolutely pertinent that real engineering actually is interdisciplinary. And the more that James and I gathered data about what engineers actually do in the workplace, the more we discovered that the really successful engineers, without even being perhaps that aware of themselves, were by nature interdisciplinary. They knew I remember once I was talking to a guy who was head of for all Europe for Ford Motors in one particular aspect of their firm, and I asked him, you know, you started off as an industrial engineer and now you're in charge of all of Europe for customer service and returns, and how did that come about? And he said, well, that came about because I learned the languages. And he didn't mean the actual language of different countries. He meant the language of the guys on the shop floor, the language of the representatives, of the mechanics, of the marketing people. All these different you know, stakeholders have their own way of looking at things, and for an engineer to get things done, you have to be able to be familiar with those languages and be interdisciplinary in the way that you were talking about, Roger. Thanks.
Well said, Bill. Now on to Elsie.
Yes. Can you hear me okay?
Yes. Yes.
Sure.
Thank you. Well, Bill, thank you so much. I'm one of those people who on your chart is on the continuum, the interdisciplinary or maybe transdisciplinary, as Krishna and Ramiro and Hans know, the world that we live in is more the world of the World Economic Forum that you referenced earlier, which is we help organizations and leaders to get their arms around meta trends in a way that moves the business climate forward and their organization's success. And one of the things that you mentioned is particularly important now in the business community. Not only do engineers face this challenge of acquiring more human relational skills, whether it's negotiating, as you mentioned, or cognitive flexibility, or people management, emotional intelligence, so too with the business schools. And they have been trained in a very narrow way to drive profitability, and not necessarily in a way that includes the interests of society. And I think we're seeing the effects of that now. So one of my questions is, Bill, in reviewing the research that's being done or has been done, is there any that's being done in collaboration with the business school educators who are trying to help their students acquire the same skill sets? That was one of my questions. And the other is, it wasn't mentioned, but I had the privilege of working with Ramiro last year in helping to curate that particular one of those sessions of the GEDC WEEF 2018 conference, which was dubbed the Peace Engineering Conference. And some of the materials, that was interdisciplinary, and some of the materials associated with that and resources are available on a website, peace-engineering.org, that Ramiro set up, if that would be of use to anyone.
Want to take that, Bill?
Right. So thank you, Elsie, for mentioning the Peace Engineering resource. Yes, I attended the webinar earlier this year on that, and yes, that's a very relevant aspect. And in terms of collaboration with business schools, I haven't seen that many actually that I can recall offhand. But the area of entrepreneurship, there have been some articles in JEE and EJEE in the area of engineering and entrepreneurship that I think have involved some collaboration, but I can't recall offhand like specific authors. But I think that's the area where there is most likely to have been that kind of collaboration, in fact.
Okay, so I'm going to go to the audience participants here and read out some questions and comments, some of which might have already been discussed in the discussion. Patricia Xavier, has working interdisciplinarily, made you view engineering as a sector differently to before?
Yeah, well, I'm happy to answer that one. In fact, it was kind of the opposite. It was when we started looking, going into firms, going into enterprises, interviewing people, then interviewing engineers in the workplace, and then analyzing those transcripts. That was when we began to realize that there's a whole lot more to successful engineering and successful engineers than what I had originally sort of defined in my head as what engineers do. And an interesting aspect that we found in our research, both James gathering data in Australia and South Asia, and me gathering in Portugal, we found that in many cases, the people we were talking to would say, well, I do very little real engineering these days. And we're talking to somebody who seems like an extremely successful engineer, and he says, or she, and many female engineers also, and they're saying they don't do real engineering. So then you ask, well, what do you spend most of your time on? And they say, well, it's like management, or sometimes it seems like politics, or one of James' respondents said, well, it's kind of random madness. And then, though, if you ask, well, if you're not doing much real engineering and most of your time is management, does that mean that somebody with a business school, a management degree could come in and take over your work? So, well, of course not. So it was from that pointed us actually to interdisciplinary work. And we realized that real engineering involves a lot more than many real engineers themselves realize, because they're doing it intuitively. They've learned that you have to talk to people, you have to listen to people, you have to interact with clients, colleagues, whatever, to get stuff done on time and within budget. And a lot of that doesn't seem to them like real engineering, because it's not what Roger was saying, it's not engineering science. But in that way, we were forced, if you like, or we were led to realize that engineering is much more interdisciplinary than we had realized. And that was what, I guess, moved us into, or forced us, if you like, to move into interdisciplinary research.
Okay, thank you. This is from Mauricio Dweck. Thank you so much for your constructive presentation. You mentioned social skills that need to be taught to engineering students today. However, could you comment on the other side of interdisciplinary engineering education, that is the social applications and functions of engineering, such as social and sustainable development? Where do you see the current engineering education research's role?
Yeah, well, I think the Peace Engineering Initiative, the grand challenges, and we've had excellent webinars on these topics earlier this year. They show us that to any thinking person, really, the future will involve engineers working in a way that will make our planet more sustainable and considering the social applications of engineering. And there are many examples that if I had more time, that we could give, where the absence of these have ended up creating engineering disasters. And like Michael Milligan was saying, even also from an ABET perspective, ABET already sees that as an essential area of engineering and engineering accreditation in the future. And the other aspect of that is in terms of making engineering more attractive to bring in a broader and to bring in more students to our courses. As a general rule, if you look at the MIT report that came out last year on the state of the art in engineering education, and they identified various engineering schools around the world that were seen as most innovative and most successful, and many of those had a strong focus on what you mentioned there, Mauricio, the social applications of engineering and sustainability and so on. So I couldn't agree more with your point, Mauricio.
Ramiro, I noticed you're unmuting yourself. You want to jump in, Ramiro? Here's your chance. Go ahead. You unmuted yourself, but we're not able to hear you. Come in, Ramiro. Ramiro? No? Okay. Okay, I'm going to just a couple of quick comments before we leave. I have a comment here from Alida Hermida. Disappointed because I have problems with audio. Words such as interdisciplinary, originality, conversation, interrelation, they all allows us to teach engineering in a more complex world, and I look forward to listening to the webinar and recording. Yes, we will be having a record. We have a recording made, and you will be, all participants will be sent a link to the recording. Then we have a couple of comments from Deepak Waikar about whether the what are the challenges do you envision from, because of the specialties in various higher education? What are challenges do you envisage for making transition from specialists to multidisciplinary engineers? And do you want to address that, Bill, before we wind up?
Yeah, well, we all know that there are huge challenges there and involve us perhaps, well, will involve us rethinking our engineering curricula. And like I said, some of the earlier webinars have pointed in this series have pointed us in the kind of directions I think that we need to go. And also, I think that MIT report is worth having a look at to see what's going on in some of the engineering schools in various parts of the world that have been identified as particularly as showing signs of leadership and so on. I think it's worth having a look there. You mightn't agree with what they're doing, but in the various institutions, but I'm sure it'll give you, number one, perhaps some ideas of how you might think about introducing change in your own context, and also the fact that it's not, Bill Williams in a webinar saying something. It's a report, an MIT report, which has some perhaps credibility in terms of getting management buy-in in your own institution, which isn't always, the easiest. Introducing change is, as we know, and the things that we're talking about here will oblige us to change some of the ways that we think and some of the ways that we do things. And those institutions who are willing to take on those things are likely to be successful and their graduates will be successful in the future.
Okay, thank you, Bill. Just a quick commercial as we close. The WEEF World Engineering Education Forum 2019 is coming up in November. Bill will be a speaker there as well, and and this is the website weef2019.org. It's going to be from 13th to 16th November at ITC Grand Chola. They have extended the deadline for submission of abstracts, and as James has pointed out, hey, this is a good place to begin if you're not ready for the prime time with some of the journals that are harder to get in. And you get to see Taj Mahal also if you want to make a special trip there. So please, come in, look at the website, look at the detailed submission process, and come on over. And it's fantastic. We've had almost 110 people to this presentation, and wish you all the best. And thank you so much, Bill. This has been a terrific discussion, and we look forward to continuing these discussions in other forums. Thank you, Bill. Any last words?
Thank you very much, Krishna, and thank you for all the contributions. I've made a note of the various suggestions and comments, which actually are very useful to me also for future talks. So thank you very much.
Thank you.